In this video, we are going to look at our arithmetic sequences. Sequences are a list of numbers. With an arithmetic sequence, we have a list of numbers where the difference between any two terms is constant. So we are looking at going term to term, and I'm either adding or subtracting the same thing each time. Now, this makes arithmetic sequences form a linear pattern because that common difference is the same, or that difference is the same. So we call that our common difference. We label it with a lowercase letter d, and it's just the difference between any two consecutive terms. What it ends up being is the slope of our line. So these are our two definitions that we need. We're going to look at a couple of examples where we are just going to determine if a sequence is arithmetic. What we're going to do in order to do that is look for that common difference. If there's a common difference, then it is arithmetic. If there is not a common difference, then it is not. So those are our instructions. Determine if it's arithmetic. If it is, give the common difference. And let's look at example 1. So here's my list of numbers. I could write it as a table if I wanted to, but I'm just going to use it just as is and figure out what I'm adding to get to each term. So there, 5 plus 3 is 8, 8 plus 3 is 11, 11 plus 3 is 14, 14 plus 3 is 17. So since that's all the same, this one is arithmetic. And my common difference is that 3. Now, when we go to write our equations, that 3 is going to be our slope. Example 2. So I can look at example 2 and see that it's not going to be, because there I'm adding 1, there I'm adding 1, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8. So that one is not arithmetic. And then example 3, we are getting smaller this time, so we're subtracting or adding a negative. So 35 plus negative 12. If you're not sure, just do 35 minus 23, it gives you 12. So you're subtracting 12. And then 23 minus 12 is 11. 11 minus 12 is negative 1. Negative 1 minus 12 is negative 13. So this one is arithmetic with a common difference of negative 12. Now, if I wanted to write an equation here, it's going to be this form. Y equals mx plus b. It's going to be linear. I could have done standard form, but I chose mx plus b because you know what? I already know that negative 12. I already know my slope. Now, I'm going to show you a different way to find your y-intercept, but look how simple it's going to be. This is your a sub 1. Your y-intercept would be your a sub 0. So all I need to do is figure out what minus 12 is 35. So I'm backtracking 1. So I'm just going to do 35 plus 12, which is going to give me 47. That would be my y-intercept. I'm going to give you a different equation, but I just want to show you if I were asked to write this in slope-intercept form, that's one thing I could do. I could backtrack to that original a sub 0 term. Even though we don't really do a sub 0, we start at a sub 1. That would give me my y-intercept. Another way to go about it, and a formula that's used quite often, so it's worth memorizing, to find the nth term of any arithmetic sequence, we can do a sub n, so that's your nth term. That right there is your nth term. I'm going to do my common difference times n minus 1 plus a sub 1. That's our first term. It's not a sub 0, so it's not my y-intercept. That's why I need to do n minus 1. That's that backstepping to a sub 0. That's where the n minus 1 comes in. So let's use it, and hopefully it'll make a little bit more sense to us. we are going to write a recursive and an explicit rule for each arithmetic sequence, then find the indicated term. So we're going to go through, first we're going to do the recursive. The recursive is actually simple. We'll do that pretty quickly. The explicit, we're going to use this formula for. So this formula gives us the explicit. And then we're going to find the term that's asked for. We're going to do 2 examples, starting with example 4. Okay, so the first thing I need to do is find my common difference, right? So -5 to 1, I'm adding 4. They told me it was arithmetic, so I know I'm going to be adding 4, but I'm just going to double check. And what that means is my common difference is 4. So I've got 3 parts to this. My first part is to find my recursive. Remember, the recursive is the one that depends on the one before. So I'm going to take the one that came before, that's a sub n minus 1, and add 4. So in other words, to find the 5th term, I would do the 4th term plus 4. 7 plus 4, the next term would be 11. So that's my recursive. My explicit, I'm going to use my a sub n equals my common difference times n minus 1 plus a sub 1. So the a sub n is going to stay a sub n. My common difference is 4. The n is going to stay n because that's my variable. That's my independent variable. And then my a sub 1, remember my a sub 1 is that first term. So my a sub 1 is -5. So I'm going to put -5. I could leave it like that, but I could also solve and simplify it by distributing my 4. And then combining my like terms. Now watch, if I were to do what I had done before, if I were to backtrack 1 step by subtracting 4, see how I would get that -9 as my y-intercept? And my slope was 4. So either way, use the formula or do the back step. Now to find a sub 24, a sub as in a subscript 24, I'm going to plug 24 into my explicit. I don't want to use my recursive here because for my recursive, I need the 23rd one. And for the 23rd one, I need the 22nd one. So I'm not going to use my recursive, I'm going to use my explicit. So what is that? 80 and 16, so 96 minus 9. So 87 would be my 24th term. Let's do another example. I'm actually going to have you do this example on your own, and then tomorrow in class we will talk about it. So here is your example 5. You are going to do this one on your own. Start by finding your common difference. Then you're going to do your explicit. Then you are going, your recursive, then your explicit, and then you're going to find the 15th term. So pause here and complete this one. It does need to be completed when you submit your notes, and then tomorrow we will go over it. There are 2 more that are try these, and they're a little different. But I want you to just think through them and try them on your own. And again, we will go through them together in class tomorrow. I'm trying to make the page smaller so you can see all of them. So those last 3 examples you are trying on your own. These 2 I haven't told you how to do, so you're just going to play around with them. They don't have to be right, but I want to see that you have attempted them in some way, shape, or form. Remember, you are taking a picture when you are done and submitting it. Oops, that's not what I wanted to do.